Hello and welcome back in another video. Here we are going to solve the last 5 questions from October-November 2020 Pure Mathematics 3, and it is 9709, component is 31. So here is the question number 7. A part, verify that -1 plus root 5 iota is a root of the equation this. So we verify by putting this value in it. So if this is it is to prove that it is a root, let's take it as x as -1 plus root 5 iota, and since we require x square and x cube, we'll calculate these all first of all. So x square is going to be x into x, that is -1 plus root 5 iota whole square, and here we are going to use iota square as -1, and we will get it as -1 whole square, a plus b whole square identity, and it is minus, so it's like a minus b whole square identity. It is going to be -5 and -2 root 5 iota. So it become altogether -4 -2 root 5 iota. I have used iota square as -1, that's why it become -5. And now the last one, x cube is going to be x square into x, so it is -4 -2 root 5 iota. We will calculate this. This is x square, we have calculated earlier, and this is x. So again we are going to multiply and check what is answer. -4 into -1, 4, and this -2 root 5 iota into root 5 iota, iota into iota, iota square, that is going to be -1, so it will become plus, and 2 5s are 10, and then this into -4 into root 5 iota, that is going to be -4 root 5 iota, and here it is going to be plus 2 root 5 iota, which will be completely 14 -2 root 5 iota. Now this will substitute in it, and we'll check if left hand side is equal to right hand side. So left hand side, it is 2 into x cube, so 2 times 14 -2 root 5 iota plus x square, so it is -4 -2 root 5 iota plus 6x, so plus 6 times -1 plus root 5 iota, and -18, and we will simplify. 14 2s are 28, 2 2s are 4 root 5 iota, -4 -2 root 5 iota, -6 plus 6 root 5 iota, and -18. Now we can see it is 28, so 28. Now here it is -4 -6 -18 is -28. Again here it is -4 root 5 -2 root 5 become -6 root 5 iota, and it is 6 root 5 iota. So altogether it is 0, and hence that is going to be right hand side, and hence -5 plus root 5 iota is a root. Now I think that's it for this part. Let's do the second part of this question. Here is the second part. Find the other roots of this equation. So I'll write the equation here. Now this is the equation, and we have from the first part that x is equal to -1 plus root 5 iota is a root of this equation. So the second root would be, of course, this is going to be complex conjugate of this, and the complex conjugate of -1 plus root 5 is -1 minus root 5 iota. So this is the second root. Let's say the third root, because there are going to be 3 root, it's a cubic equation, so let's say the third root be a, and if this third root is a, then it means if we'll multiply these three, the factors, those three factors means x minus this complete things minus 1 plus root 5 iota, that is going to be x plus 1 minus root 5 iota. From here the factor become x plus 1 plus root 5 iota, and from here the factor become x minus a from the factor theorem. If these are the roots, then these will be factors. So if we multiply these all, we should get the equation. We should get this equation. So it is going to be x plus 1 minus root 5 iota into x plus 1 plus root 5 iota into x minus a is equal to 0. Then this must satisfy this equation. It will give the exact equation which is there. So we will multiply, we can compare the coefficient to get the value of a, and that would be the third root. So it is going to be, we'll multiply, and it is the first two terms will give, it is of the type x a minus b and a plus b. So it is a square plus b square, a square minus b square, and that is going to be x plus 1 whole square, I'll write square bracket here, minus root 5 iota whole square, and multiplied by x minus a is equal to 0. So we'll simplify this and we'll get x square plus 1 plus 2x, and from here we'll get 5 iota square, that is going to be minus 5, and minus 5 will become it become plus. So plus 5 plus 1, it is going to be 6. So x square plus 2x plus 6 into x minus a is equal to 0, which will be, now we will multiply and compare the coefficient. So multiplying this two, we will get x cube plus 2x square minus plus 6x minus ax square minus 2ax minus 6a is equal to 0, or we can write it as x cube plus 2 minus 2a x square, ax square plus 6 minus 2ax minus 6a is equal to 0. Now if we'll compare these two equations, that should be same, and it is the coefficient of x cube is 2, so we can make it same by dividing the whole equation by 2, and we will get it as x cube plus 1 upon 2x square plus 3x minus 9 is equal to 0. We got this by dividing this whole equation by 2. So now we can compare, x cube coefficient is 1. Now from x square we will get 2 minus a is equal to 1 upon 2, and we will get it at from here a is equal to 2 minus 1 by 2, that is 3 by 2. And we can cross check whether we are getting the right answer or not, because this will get we will get the same value from all the coefficient. And from the x coefficient we see 6 minus 2a is equal to 3, so it become 2a is equal to 6 minus 3, that is 3, and upon 2 same. And from the last one also 6a is equal to 9, so a is equal to 3 by 2. So finally the other root is, the next root is going to be x is equal to 3 by 2 is third root, is the third root. So second root is minus 1 minus root 5 iota, first root is already given, and third root is 3 by 2. And we could have done it by simply dividing it, because when we had two roots, we could have simply multiplied their factor, that is x plus 1 minus root 5 iota into x plus 1 plus root 5 iota, and we could have divided this polynomial left hand side, and we could have got this direct answer, x minus 3 by 2, and that would be x is equal to 3 by 2. So I hope it is clear. Let's do the next question. Here's the question number 8. The coordinates xy of a general point of a curve satisfy the differential equation x dy over dx is equal to 1 minus 2x square into y for x greater than 0. It is given that y is equal to 1 when x is equal to 1. Solve the differential equation obtaining an expression for y in terms of x. So we have this, we know that method to solve the differential equation. When we have the things like that, we do the variable separable. We will do the variable separable and we will get it as dy over y integration of this is equal to 1 minus 2x square over x and then this dx. I'll transfer this here, x and dx over there and y this side, and it become ln y is equal to, we could have written it like that, 1 over x minus 2 times it is dx, 2 times I am separating it, 2x square over x, that is x dx. Now we can do the integration easily. It is going to be ln x minus 2 and integration of x square, x is x square by 2, that is 2 cancel and we got only x square, and plus constant of integration c. So from here we have the condition when x is equal to 1, y is equal to 1. So we will get it as ln 1 is equal to ln 1 minus 1 square, that is 1, plus c. So we know that ln 1 is 0, ln 1 is 0. So from here we got c as 1. So once we got c as 1, we will write it as ln y is equal to ln x minus x square plus 1. Now we will write the expression for y in terms of x. So let's separate it. I will collect the logarithm terms. So it is ln y minus ln x, so it become ln y upon x. This will transfer, we will transfer it here and it will become ln minus ln x, so ln a minus ln b is ln a over b, so it become 1 minus x square. I'll write 1 first because it's a positive quantity, and then we will take it as, we will write by the definition y over x become e raised to the power 1 minus x square. So finally we will write y in terms of x, that is y is equal to x into e raised to the power 1 minus x square, and that is the solution of it. So I hope it is clear. Let's do the next question. Here's question number 9. Let fx is equal to 8 plus 5x plus 12x square over 1 minus x into 2 plus 3x square, and we need to express fx in the partial fraction form. So we can see it is linear and it is linear factor but square, so we can write fx as, I will write it as a over 1 minus x and b over first power and the c over the 2 power here. Now we will solve for a, b, c, and that is going to be the answer. So let's multiply the whole equation by the denominator, and then we will get it as 8 plus 5x plus 12x square is equal to a times 2 plus 3x whole square, because there is no denominator of 2 plus 3x whole square, and b times 1 minus x and 2 plus 3x 1 power, because there are 2 powers we are multiplying, and plus c times 1 minus x. Now we'll substitute some values of x so that we can get the values of a, b and c. So the first one, the easiest one is to get is, let's put x is equal to 1. When we will put x is equal to 1, this will be 0, this is going to be 0. So we will get 8 plus 5, 13 plus 12, 25 towards the left hand side is equal to a times 2 plus 3, 5, and 5 square is 25, so it is 25a. This means a is equal to 1. Now we will put x is equal to, let's say it is 0, or we can get directly the value of c. If we put x is equal to, we will put this as 0, that is x is equal to minus 2 by 3. So x is equal to minus 2 over 3, and it's little bit complicated, but that is going to give you the value of c directly. So 8, and it is 2 into minus 5 into minus 2 over 3, that is minus 10 over 3, and plus 12 into x square, that is 12 into 4, 48 over 9. 48 over 9 is equal to, this becomes 0, this also becomes 0 because it is 2 plus 3x, and this 1 minus minus 2 by 3, that is 1 plus 2 by 3, it is 5 by 3 here, 5 by 3 c. So now we will solve the left hand side, and left hand side if you'll simplify, it is going to be 10, completely 10, and it is going to be 5 over 3 c, which will give c value as 3, 5 2s are 10, so c value is 6. So now we have a value and c value. Let's put anything to get the value of b. The easiest one is, let's put x is equal to 0. When we will put x is equal to 0, this is gone, this is gone, we are left with 8 towards the left hand side, and right hand side it is going to be 0. So 2 square 4 times a, 4 times a is 1, because a is 1 here, 4 times 1, plus b times 1 minus 0, 2 plus 0, so it is 2 times b, and plus x is 0, so it is c, so plus 6. It means this is 4, and sorry, it is 6, 4 plus 6 10, and it is 8, so minus 2, and hence b become minus 1. And that's why the fx, the partial fraction, will express fx as a over 1 minus x, that is 1 over 1 minus x, b over 2 plus 3x, that is minus 1 over 2 plus 3x, and plus c, that is 6 over 2 plus 3x whole square. And that's the answer. Let's do the b part. Here's the b part. Hence obtain the expression of fx in ascending power of x. So from the previous part we got fx as 1 over 1 minus x plus minus 1 over 2 plus 3x and plus 6 over 2 plus 3x whole square. So now we need to find the we need to expand it till up to and including the term in x square. So we know the expansion of 1 plus a whole to the power n. So if we have this for any n, so we require to get 1 here first of all. So what I will write once again this as 1 minus x minus, I'll take 2 common, so it become 1 over 1 plus 3 by 2x and plus 6 over 2 common, so it is square, so it become 2 2s are 4 times 1 plus 3 by 2x whole square. I think we can understand it here because 2 plus 3x whole square, so if you take 2 common, so it would become 2 times 1 plus 3 by 2x whole square, and take 2 square outside, become 4. Now we can write it as 1 minus x to the power minus 1 minus 1 upon 2 times 1 plus 3 by 2 x to the power minus 1 plus 6 by 4, that is 3 by 2 times 1 plus 3 over 2 x to the power minus 2. Now we can expand it till so now we will expand with this formula identity, and that is going to be 1 minus x to the power minus 1. We will take a as minus x, so we will get 1 and plus n times a, that is minus 1 into minus x, that is plus x, and plus minus 1 into minus 1 minus 1, so it become minus plus 2 and into x minus x square, that is x square, divide by 2 factorial, and plus so on, and we want to write it minus 1 by 2 into this again, so 1 plus NA, that is minus 3 by 2 x, and plus minus 1 into minus 1, that is going to be plus 2. So plus 2 and 3 by 2 x whole square and divide by 2 factorial, that is 2. And no need to write the next term because we require to write till x square. And the last one is 3 by 2 and it is 1 plus NA, that is minus 2 into 3 by 2 x, and plus minus 2 into minus 2 minus 1, that is plus 6. So plus 6 and 3 by 2 x whole square divide by 2 again, 2 factorial, that is 2, and plus so on. We don't want to write that, and it is going to be 1 plus x square, and here plus and so on, plus minus 1 by 2 times 1 minus 3 by 2x. These two got cancelled and we got it as 9 by 4 x square, plus and so on, plus 3 by 2 times this. We can see these two got cancelled, this got cancelled, it is 3, and we got 1 minus 3x plus 3 into 9, that is 27 over 4 and x square, plus and so on. So it become, we'll collect them all, and it is 1 minus 1 by 2 plus 3 by 2 is 2, plus x coefficient, it is 1 here, 1, and it become plus 3 by 4, 1 plus 3 by 4 is 7 by 4, and then it is going to be minus 9 by 2. So it is 9 11 minus 11 by 4, 11 by 4 here, and this is going to be x. The last one is x square, so x square 1 and minus 9 by 8 and 27 by 4. So if we'll simplify, it is going to be 10 x square. So we got the final answer as 2 minus 11 by 4 x plus 10 x square, and plus so on. We don't want to write. So this is the expansion of fx till up to and including the term x square. I hope it is clear. Let's do the next question. Here's the question number 10. The diagram shows the curve y is equal to 2 minus x into e raised to the power half x and its minimum point m. Find the exact coordinates of m. So we know that for maximum or minimum point, dy over dx, that is differentiation of this, derivative of this with respect to x, is 0. So first of all, let's calculate dy over dx, and we can see it is going to be multiple of two functions. So we'll use the product rule, and product rule is first function as it is, differentiation of second function, that is e raised to the power minus 1 by 2x into the differentiation of this, because it's a chain rule, so it is going to be minus 1 by 2 here, plus second function as it is, and differentiation of first function 2 minus x is going to be minus 1 only, because 2 is constant, and this should be 0, or we can simplify and write it as this is minus 1 by 2 into 2 minus x e raised to the power minus 1 by 2x and minus e raised to the power minus 1 by 2x is equal to 0. Now we'll need to simplify, and we know that exponential function is never going to be 0, so we'll cancel it and we'll get it as 1 minus 1 by 2 minus x minus 1 is equal to 0. That is going to be we can cancel this minus plus, and it become 1 by 2 times 2 minus x become minus 1, or we can write 2 minus x is equal to minus 2, or this will come here and x value is going to be 4. So we need to find the exact coordinates of m. We have x is equal to 4, so we'll put x is equal to 4 here, and we will get y value. Y value is going to be 2 minus 4 into e raised to the power minus 1 by 2 times 4, which is going to be 2, and it is minus 2 e raised to the power minus 2. and since we need to give the exact coordinates of m, so we'll write it as m as x coordinate 4 and y coordinate is minus 2 over e raised to the power 2, because it was we can write as it is as well, but power is, in order to make it positive, I transfer it into the denominator. So that's it. Let's do the B part. Here's the B part. Find the area of shaded region bounded by the curve and the axis. Give your answer in terms of E. So first of all, I'll bring the diagram here. So here's the diagram. In order to find the area by shaded region, it means we need to find first of all this point, so that we can use the integration formula from 0 to this point, integration of this function dx. So for this point, the curve, since the curve is y is equal to 2 minus x e raised to the power half x. So for this point, let's say it is, this point is a, for a or at a y is equal to 0, and hence 2 minus x e raised to the power minus 1 by 2 x should be 0, and we know that it cannot be 0 ever. It means x should be 2. So we got x coordinate as 2 here, so this point is 2, and here it was 4, we have seen in the previous part. Now in order to find the area, so area is going to be integration from 0 to, from this, because this is some origin, 0 to 2 y dx. Y dx means 2 minus x into e raised to the power half, negative half x dx. That is what we need to find. And we can see there are two functions again, so we are going to use the integration by part here. We will take this as first function and the second function as this. So it is going to be, I'll put the limits afterwards, so I'll write the square bracket here. It is 2 minus x first function as it is, and different integration of second function. Integration of second function means e raised to the power minus 1 by 2 x, and divide by the differentiation of this, that is going to be minus 1 by 2. This is the integration. This is the integration of e raised to the power minus 1 by 2 x, and minus integration of differentiation of the first function, that is going to be minus 1, into integration of the second function, that is this part again. So it is going to be, I am going to write it as minus 2 e raised to the power minus 1 by 2 x, and whole, and then integration. Again the limit I'll put at the last, so I'll write it as this. So it become 2 minus 2, so minus 2 into 2 minus x to the power into x to the power e raised to the power minus 1 by 2 x, and here minus minus plus, so it become minus, and integration of the whole thing, this integration of again this, and we have the integration of this as minus 2, so I'll write it as minus 2 e raised to the power minus half x, and the limit 0 to 2. Now we'll simplify, we'll see if it can be simplified anymore. If we can see, it is minus 2 into minus 2 is minus 4 e raised to the power minus half x, and minus minus plus 2x e raised to the power minus half x, and here it is minus minus plus 2 2s are 4 e raised to the power minus half x, and the limit from 0 to 2. We can see these two are same, so we'll be cancelling it, and the last answer we'll write the upper limit is 2 and lower limit is, since it is 0, so it will be 0. The last answer would be 2 into 2 e raised to the power minus 1 by 2 into 2, which will give us 4 over e, because it's e raised to the power minus 1, so denominator it become only e. So the area is 4 over e square unit. That's it. Let's do the second question. Next question, that is 11th question. This is the question number 11, that is the last question of this paper. Two lines have equations r is equal to 1 plus 2 j I plus 2 j plus k plus lambda times ai plus 2 j minus k, and r is equal to 2i plus j minus k plus mu times 2i minus j plus k, where a is a constant. Given that two lines intersect, find the value of a and the position vector of the point of intersection. So it's like if this is a line, first equation of line, so this point is, let's say, I plus 2j plus k, that is 1 plus 1 2 and 1, and this direction vector is going to be ai cap plus 2j cap minus k cap, and this another one is, let's say this point is 2I cap plus j cap minus k cap, and the direction vector, it can be this or that, 2I cap minus j cap plus k cap. It says that they intersect. If these two intersect, so it means for some lambda and for mu they are same. So it means if they intersect, it means we can make them equal. So making them equal, we can write it as I plus 2j plus k plus lambda times ai cap plus 2j cap minus k cap is equal to another line, that is 2I cap plus j cap minus k cap plus mu times 2I cap minus j cap plus k cap. Now we will equate the coefficient of I, j and k, and we will find the value of a. So let's write it together as I, j and k coefficient. So it become 1 plus 2a I cap plus 2 lambda also, because it's lambda we will multiply. So it is 2a lambda I cap plus 2 lambda j cap and plus 1 minus lambda k cap, and the right hand side would be 2 plus 2 mu I cap plus 1 minus mu j cap, and the last one minus 1 plus mu k cap. Now equating them, the last k coefficient, so is going to be 1 minus lambda is equal to minus 1 plus mu, which will give it as let's write mu plus lambda is equal to minus 2. I transfer it here, so minus plus, so it become plus 2, sorry. And equating the j coefficient, we will get 2 plus 2 lambda is equal to 1 minus mu, that is mu plus 2 lambda is equal to minus 1. And similarly for I, we will get 1 plus 2a lambda is equal to 2 plus 2 mu. So once we will get the lambda and mu from here, we will put it here to get the value of a. So solving this, let's subtract the first equation from the second one. We will get lambda is equal to minus 3, minus 1 minus 2 is minus 3, and this lambda, and when we'll put lambda is equal to minus 3 here, we will get mu minus 3 is equal to 2, that is lambda mu is equal to 5. So we got lambda is equal to minus 3 and mu is equal to 5. So from here we got 1 plus 2 times minus 3, so minus 6a is equal to 2 plus 10, or we can write it as 6a is equal to 10 plus 2 12 minus 1 11, or a is equal to 11 over 6. So a value is 11 over 6 now. And now for the value position vector of the point of intersection, for this we know these two are going to be same, so we'll put either lambda is equal to minus 3 to get this r, or mu is equal to 5 to get them. So that is going to be same for all. So let me choose mu is equal to 5, and I'll replace it here in the second one, and we will get 2I plus j cap minus k cap plus 5 times 2I minus j plus k. So it become 2 plus 10 12 12I cap, j minus 5, that is minus 4j, minus 5 plus 5 minus 1 plus 5, that is going to be plus 4k cap, and that is the position vector of point of intersection. We can mark it as P. So this is the position vector of P. So I hope it is clear. Let's do the B part. And here's the B part, that is the last question. Given instead that the acute angle between the directions of two lines is cos inverse of 1 over 6. So this time the acute angle is given. Find the two possible values of A. So let me bring the lines, equations of lines. So since these are the equation of line, it says that the acute angle between them is this. So we'll mark and we measure the angle in the angle between the direction vectors. So we can write it D1 as the first direction vector as a I cap plus 2j cap minus k cap, and another direction vector D2 is going to be 2I cap minus j cap plus k cap. Now we have two direction vectors, so if we want to find the angle, we have the formula of if we have vector A and vector B, then it is dot product is going to be modulus of vector A into modulus vector B into cos of the angle between them. So we'll use this formula here, and we'll find first of all the D1 modulus of the first direction vector, that is going to be square root of A square plus 2 square, that is 4, minus plus minus 1 square, that is going to be 1, that is root of A square plus 5. And similarly the modulus of second vector, that is this, is going to be square root of 2 square is 4 plus 1 plus 1, that is root 6. And dot product of these two, D1 into D1 dot D2 is going to be A into 2, 2A plus 2 into minus 1 is minus 2, minus into plus, that is going to plus minus 1. It is going to be 2 minus 3. Now we will substitute this these values here to get the cos theta, and we can understand from here that theta is equal to cos inverse of 1 by 6. So cos theta would be 1 by 6. Now I'm going to substitute it here. So we'll get 2a minus 3 is equal to root 6 into root a square plus 5 and cos of theta, that is 1 by 6, or we can write it as 6 into 2a minus 3 cross multiplying is equal to square root of 6 into a square plus 5. Now squaring both the side, we will get 36 times 2a minus 3 whole square is equal to 6 times a square plus 5, removing the square root, and it is, now we will simplify, it is going to be 6 times 4a square plus 9 minus 4 3s are 12a is equal to a square plus 5. Now we will make a quadratic in a, and it becomes 24a square minus 12 6 are 72a plus 6 9s are 54 minus a square minus 5 is equal to 0, or we can write it as 24a square minus 72a, sorry, it is 23 now. So this become, we can write it as 23a square minus 72a, and 54 minus 5 is 49 plus 49 is equal to 0. Now we can see the sum of these two, 23 and 49 is 72, and product we can get directly, so it can be simplified as 23a square minus 23a minus 49a plus 49 is equal to 0. We can use the formula, quadratic formula as well. 23a common, and it is a minus 1, minus 49 common, it is a minus 1 is equal to 0. So we got two values of a, that is 1 and 49 over 23. So these are the two values, that is what they have asked. So that's it for this video. I hope it was of some help. Thank you so much. I hope it was of some help. Thank you so much.